All right, so this is lesson 10. It's exploring the hardness of your minerals. All right, so you will need your 12 minerals. If you're doing this from home, you might not have all your minerals. And you do need a copper penny, not a new penny, but an older penny, I think pre 1982. So it's copper. Um, and, uh, and a nail. All right, so to start off, the hardness is a resistance to scratching. It's a very important property of minerals. A mineral's use is often related to its hardness. So how it can use, if it's really hard or really soft, really depends on how people are going to use that mineral. All right. So remember, hardness and durability are a little different. Okay. Scratching and breaking are two different things. Usually, yes, if it's very hard to, it is pretty durable. But just because it's hard doesn't mean it can't break. Okay. So hardness is the resistance to scratching. That's super important. Scientists classify them using the Mohs scale of hardness, which we'll go over. And it's just like a little scale, so we can all be using the same kind of scale and test things out. Um, all right. So Friedrich Mohs was the guy who created this scale of hardness, and this it's how kind of the strength of the bonds of the crystals. So how the inside stuff is holding together. If it doesn't hold together really well, it's gonna scratch easier. So resistance to scratching means like it doesn't, it doesn't want to be scratched. Okay. We test using regular items that you can find or different minerals. Sometimes I'll use. So on here is his scale of hardness. It goes from talc, which you guys have experienced already, which is like a soapstone. Soapstone's a little harder. Talc is a mineral. Soapstone's a little bit metamorphized, so it's a little harder. All the way up to diamond. We'll go over these in a second. So I know he's a little creepy there. Mohs knows. That's a good way to do it. Mohs knows his minerals. Okay. So talc is number one, gypsum is number two, calcite, that's the one that bubbles with the acid, is number three. You will have one of these. You'll have one of these. Fluorite, which you have also, is number four. Apatite, feldspar, which is one of the most common, and feldspar and quartz are the two most common minerals on the crust. This is about the hardness of glass, because a lot of quartz is made out of, like sand quartz and all that is made into glass. So these two are often made into glass. This one will be often found in your red granite. Topaz, corundum, which is like ruby and sapphire, and then diamond is the hardest. It means it will scratch everything else. So again, if I had a diamond, it can easily scratch the quartz. The quartz can easily scratch the fluoride. Fluoride could easily scratch the talc. All right. They put numbers onto these two all the way across. So again, and what we do is we use common things that we out in the field, because I'm not going to have a set of minerals to scratch against too often. I'm just going to want to know kind of where it's at. So I'm going to use my fingernail, a penny, which is copper, and a nail, which is usually 6.5, and put it in between. Now, yes, I'm going to, if I was a mineralogist and I was really interested, seeing where this mineral was, I would bring a sample back and test it and get an exact hardness. Okay. But out in the field, you're not going to be sitting there doing it. You're just going to do a quick one. And so you're going to be doing something like a field geologist will do, which means you're going out in the field. You're not going to be carrying all these different samples around with you. And then you're going to get an idea of what it is, because sometimes they're huge. These outcroppings of rocks that you're out, say you're hiking in a mountain, you want to know what the mineral is. And it's just huge amounts. You just want to know a little bit. You're just going to take a little quick sample, try to figure out what the mineral is, and get a quick hardness on it. And if we're studying that outcropping and say you're going to be just in one location looking at those minerals, yes, you would take samples back to the lab and then and then be more specific. These guys would do a quick one and then put a little sample back, and maybe if they needed to double check and back in the lab, they would. All right. So again, I'm just going to stress that diamond is the hardest natural material, the resistance to scratching. A lot of times these form in octahedral diamond patterns like this. So this is how it'd be formed in nature. It comes like this, and oct means 8, so it has 8 different sides to this. Hedral means faces, flat faces. So it has 8 flat faces, and if you count them, there's 4 on the top and there's 4 on the bottom. And right about here, they kind of cleave it off if they're going to cut it into this nice diamond. And then they start putting all those little facets. Usually there's like 58 little facets around in here of the diamond. And they would need something just as hard to cut it. So they usually have a diamond tip saw to cut into those. And but that doesn't mean that it's durable, because if I stomped on this, it's going to break. Okay, and there's a story about like in the past, a czar, like is like a Russian czar, just like a king who was boasting about how diamonds are tough, and he took one of his diamonds from his collection, a big one, and said, "I could stomp on it with my boot," and he did, and it shattered. And he said, "I don't understand. It's the hardest. Why would a boot crush it?" Well, because he just hit it right, and it cleaved and broke. I mean, it's just like if you broke glass. Glass is very hard. It's a 7, but it breaks really easy. So, if you just hit it right, it's going to break. So, yep. So that the hardness is resistance to scratching only. Now, I do say that diamonds are still pretty tough. Like, if that guy didn't just hit it right, his diamond would have stayed together. All right, so we're going to use the simple of Mohs. Remember Mohs scale, Mohs nose is minerals. So he wanted all geologists to kind of come up with, a scale that everybody can use. So if he says it's a hardness of 2, and then he sends it up, everybody will be using the same scale. Kind of like if everybody uses centimeters, everybody be using the same scale. So we're going to just simplify it like a field geologist will do. Just put it into soft, medium, or hard, and I'll show you how to do that in a second. All right, so here's what you're going to do. You're going to scratch your sample of mineral A with the copper penny. Now, again, it has to be an older penny. The newer pennies have a lot of zinc in them, which is harder. So you need a mostly copper penny. So I think it's pre-1982, if I'm not mistaken. Pennies are copper. And so you're going to scratch your sample of mineral A with the copper penny. Scratch it gently. You don't want to damage it. So it's not like you're whacking it on there, a lot. You're just taking it and doing a quick right across and see if it scratched it. Now, if the penny leaves a little mark on there, got to look closely, because it could be where the copper is rubbing off, which means it didn't scratch the mineral. If the penny did leave a scratch on the mineral, we're going to put it in the soft pile. Okay, just right away, if a penny scratches it, it's soft. Okay, so that's your first one. And I'd go through all of them and just see which ones a penny would scratch. That's mine. I would go through mineral A, scratch it. If it doesn't, leave it. And then go to B. If it does, like a B, you can scratch it, then put it in soft, and go through and see which one you can first call soft. Okay, so again, it said to test it with that penny. Older pennies work better. Now you're going to focus on the other ones. Okay, so then you're going to take your nail and try to scratch it. Okay, so all the ones left, not your soft ones again. So just the ones that which are left in your egg carton. You're going to see if they can be scratched by a nail. Now you're going to take that nail, and again, you're not going to smack it in it really hard. You're just going to take it, push it on it, and do a quick right across, and see if it can leave a mark. If it does, scratch it, it's medium. If it does not, you just put it on hard. So again, this is in your book, but again, if the right away the penny scratches it, then you put it here, and if not, you leave it in your carton when you do all of them. Then whatever's left in your carton, you get your nail out, and if the nail scratches it, then it's a medium. If it doesn't scratch it, it's a hard. But again, be careful because sometimes that nail isn't leaving a scratch. It's actually leaving part of the nail on, like the metal just comes off. So rub it a little bit after you think. If it's a scratch, it'll stay in there. If it comes right off, it means you didn't scratch it. All right. So into your lab, that's where you're going to put either soft, medium, or hard on for all your samples. Yeah, and that's for every sample. So now we should have every one of these filled out except for shape. That's going to be our last one we do. And that's it for, again, remember, this is Mohs scale of hardness. Diamond's the hardest. Talc is the softest. Then it goes talc, gypsum, calcite, fluoride, apatite, orthoclase, feldspar, and quartz. Topaz, corundum, diamond. You will not have any of these up here, just so you know. You will have some of these, though. So be careful, because right around here is the trickiest ones. There's like two that's kind of tricky because you have these two, and the nails right in between there. All right. And again, try your best. Be a geologist. Think, and you can repeat that again. Try it on different surfaces and see if it'll scratch it. All right. Nose, Mohs nose. Okay, good luck.